So, okay, well, first of all, thank you everyone for being here. I hope you enjoy this talk. Thank you so much, Lauren, for being here. And yeah, I hope you guys learn a lot about like Couchbase. We are Capital. We're a tech consulting company, and we will just like show you a video so you can understand a bit of who we are, what is our culture, and yeah, enjoy the talk. So now you're good.
So when do you work?
Thank you.
We don't.
Thank you very much.
After the parties, we do.
Bottom for presenting.
Yes.
Okay. Okay. Hello, YouTube. Hello, everybody, for coming. Thank you, Lauren, for being here. Thank you, Capital, for hosting the event. I hope everybody will join. Will be happy with this event. First of all, we always do a small presentation about the community, etc. But in the case that you never come to the Barcelona joke before, because otherwise I would try to skip everything. So the typical question that we always ask is can many of you raise your hand in case it's the first time you're coming to the Barcelona Java users group? Nice. Come on, don't lie to me. So 4 people at least. Okay, so for the people that knows, you have to at least wait a little bit. Also, we can go to the next one. Yeah, so that's the boring stuff about the logo, etc. Yeah, that's true. So what we are, basically we are a non-profit organization and are people that are interested in learning stuff about Java and many things related to open source. And we are also really proud to have more than 2,000 members, which is really great in terms of having a lot of people trying to get things done, etc. And yeah, we are people curious about technology. So yeah, we would like to, let's say, do a lot of things. And yeah, what we do a lot of things. We've been doing coding dojos, practicing things, learning stuff. Or today is a good example to giving a talk and learning a new thing about a database that we don't know. And just try to grow the developer community, which is, I think, something interesting for many of you, right? That's why we are here. Yeah, many of you probably know us because of Meetup, right? For the new ones, everybody knows Meetup, yeah. We have also Twitter. In all the recordings are going to happening X, exactly. So this is not Twitter anymore. All the recordings are going to happen appear in YouTube at some point. And we have also LinkedIn group, Meetup, and Flickr, where we post some pictures there, and also the website. We have to update the website, we know, but we're backend mainly developers, so we have to do something on there. If any volunteer would like to raise their hand, that's very welcome. You're really happy to join us. We have done a lot of different events, different technologies. So if you are interested in any of those or any new ones or any that do not appear here, do not worry, come and join us. We can talk about it. We can find the person. If not, Lauren probably knows the person. If not, somebody else who knows the person, Yeah. This is the next event we are going to do. Yes, it's going to happen next week. So we are so active that we do more than 1 event per month, at least 2. It means that this month we're going to do even 3, which is crazy, but this is how we are. And we are going to have Alex Soto from Red Hat and Jonathan Villa from Sonar, who they're going to talk from one side with Podman, and another topic about clean code, right? So one is related more to Docker, somebody using Docker here, and the other thing is about writing better code. And that's it from the next event. Yeah. So as I said, thank you very much for the companies that are helping us to promote and to help this happen. Capital for hosting the event. later we are going to have something to drink and as well having some snacks. So thank you. By the way, JetBrains, who is helping us and providing some license. If any of you need a IntelliJ license or any other JetBrains license, raise your hand. We can later give you a license. And Apiumhub, who is recording the session. So thank you very much for all of you for making this happen. And yeah, we always say this is a community, so it's a matter of all of us to make things happen. And there's something that should appear here. Yes, join us and contribute. This is something that we always invite all the people. You have a crazy idea, you would like to do something, please let us know. And there is also another picture that should appear that is kind of a Slack. We have a Slack. Yeah, everybody has Slack, right? So we have a Slack where you can join and say, hey, I meet you yesterday. I would like to do something, or I would like to introduce something for you, or we are doing that in the company. We're struggling with something. Or we can try to do something. I don't know. Crazy. And today's event, thank you, Lauren, for being here. It's a pleasure to also welcome you after 7 years, 8 years? 9 years.
I wish I should have waited 1 more year. That's so sad.
Yeah.
Probably have to come back next year.
Yeah. So thank you very much for coming one more time.
Thank you.
Lauren is the Director of Developer Relations at Couchbase. So all yours, and thank you once again.
Thanks. Pleasure to be here. All right. Ça marche. Super. All right. So this is me. Is the microphone working? First thing. Do you hear my beard when I do this and it's annoying? All good. Super. So I'm here to tell you a lot of stuff about Couchbase and Spring Boot. It's going to be mostly Couchbase, if I'm honest. There's going to be a bunch of Spring Boot code that's very opinionated. That's what I can do in an hour. And if you remember, I think the last time I talked for a couple hours, maybe more. So stop me if I speak too much. So this is me. My name is Laurent Doguin. So emoji rendered differently everywhere. So that's supposed to be GitHub and then GitLab and then Twitter, but it should be an X now. And it's basically this everywhere. And La Marmotte Masquée is the name of my beer brewery that I've created with some friends, which is mostly available near Grenoble, where it's brewed, and in Paris. And we change recipe every single time, which is cool. We did a Christmas beer, which is going to be awful. I hate Christmas beer. But that's fine. We have a problem. Well, many people have many problems. Couchbase, a database that tries to, or is good at fixing one problem. Who here is using more than one data store at work? That's almost all of you, of course. And so, way too much stuff. People are using the different solutions for cache, for NoSQL. What is NoSQL? Is it JSON? Is it non-relational? I don't know. It's NoSQL, right? The database that were created after 2010. So NoSQL, relational databases. We do SQL, we do relational as well. Whatever. Query tools. Zero replication is a cool use case. It's when you need to replicate a cluster from one place to another. People do Fulltext search, and then on top of this, you bring Kafka or Apache Pulsar to do some streaming, and then you have analytics. You need to bring Databricks, and then maybe you want to synchronize stuff on the phone. So you need a mobile solution like Firebase or SQLite. And so all of those things comes up with various other issues, and most of the issues that people will get here is, well, it's the license cost, it's the burden to operate so many solutions, but very few people are actually telling main problem, which is developers have to learn all those solutions, and we are lazy, and I don't want to learn all those solutions. And so what we try to do with Couchbase is to fix all of those problems, and I'm going to show you a quick demo that is extremely opinionated, and the goal will be to simplify this. We have 3 different scenarios. The first one is I have a full-text search engine, I have a cache storage, I have a document storage. So document as opposed to relational, tables and columns. Document is, I'm storing a semi-structured data, so JSON, XML. I used to use Berkeley XMLDB. That was a full XML database, and you could query XML using XPath. That was awful, but it worked. And it was like 15 years ago, before the JSON database. So full-text search, cache, documents. Everything is linked through an event stream solution. So event streaming like Pulsar, Kafka, whatever, Red Panda for the new one. And so I have, because I'm lazy, I don't want to burden you with some actual business code. I have 4 very basic interface, one that does search, one that does cache, CRUD, and query. We don't have to go into any domain. We will just talk about those kind of operations. And so when you want to create an app that has all those features, search, cache, CRUD, and query, you use all those 3 data stores. And here you're fortunate enough to have the event streaming that coordinates everything, which is great because you don't have to link those 3 together. You still have a dependency between the cache and the CRUD service, because when you want to read something, first you need to go to the cache, see if it's in the cache. If it's not in the cache, you put it back in the cache. Sort of a little painful thing. And most of the time, if you update something here, you probably have to update this as well. So this is where you have some synchronization between everything. So it's a little bit complicated. Basically, each time you have an arrow or a link, that's an interaction that you have to take into account as a developer. So that's 8 here. You can do things manually. So doing things manually, meaning you don't have event streaming anymore. You get rid of Kafka, but then if you get rid of Kafka or Red Panda, then you have more links that are coming up in the middle because you need to synchronize everything. But still less links than before. That's more work for the developer here, and that's more work for the ops right there. Or you could use a solution that fixes everything magically, like Couchbase. That is much more simpler. And the reason it's simpler is because it's a platform. So I've talked too much. So the goal is to remove all of these gradually as soon as I can show you a bit of code. So what do we... Let's start by removing the cache and use a document database that has an integrated cache. That would be if you had caching with Mongo, or if you had Redis, for instance. They do document and they do cache, which is nice, but you still have Fulltext, so you still need something to do Fulltext. And Couchbase, yay. Time for a small demo that I haven't done in a long time, so that's going to be interesting. Everything's fine. Alors, first things first, get the right IntelliJ, make it way bigger. Hopefully that's all right. Voila. So I have my 4. Is that big enough? Should it be bigger? Am I only doing this in this window? Bloody hell. I'm so lazy. Okay, so cache. What do you do with your cache? You create stuff, you read from it, you update it, you insert it, you delete stuff. That's not cache, that's a small. All right, so cache was supposed to be bigger. Let me try to fix that properly first. That's not helping. Wait, what editor is this? Everything's fine. Voila. So cache, you write in a cache, you read from a cache, you touch a document, which means you update. It's time to leave. When you're storing something in a cache, it has it doesn't have an unlimited duration. It's going to be removed from the cache unless you have lots of memory and you're very rich and you can store everything in RAM, and that's great for you. If you don't, usually you clean things up, and and if you want to update them to make sure they stay in the cache, you can use the touch method. And if you want to remove them from the cache, you can use evict. Okay, so CRUD, we've talked about it quickly. It's create, update, upsert, delete. Everybody knows that. Query is just getting every document or searching for some document, and then I have another interface for full text search, which is a bit different. But you can see here that full text search has two additional methods that are interesting, which is index and delete, a lot like touch and evict from the cache method. So let's say that you are extremely unopinionated and you are using Mongo, Redis, and Elastic as your examples. So of course, you go and implement a cache. You can see in the cache that, well, you need to set the document in the cache. You need to add an expiration time. So here it has a 10,000 seconds life duration. So that's how you write something in a cache. Reading from cache is pretty straightforward. And then you can use, all the method that Redis gives you. Now that's good. If I go on the Elastic side of things, I can run a search. That's fine. What's more interesting is I need to make sure that each time there's something moving, it's updated, it's reflected. So there's an index and a delete method for the full text engine. So you have to implement those as well. And when do you do this? Well, if you have Kafka to do this for you, that's great. If you don't have Kafka to do this for you, then you will probably do this in the CRUD service. And you can already see that in my CRUD service, I have a couple of dependencies. So that's the tooling you saw earlier, which is basically the cache and the search interface. So I know that my CRUD service depends on both of those services. Why? Each time I'm reading something, I need to make sure, and I want to be efficient. Instead of reading it to the database, first I'm checking, is it in the cache? If it's not in the cache, well, you say, hey, it's not in the cache, which you should use a logging library, not like me. You search it through your database, you put it in the cache, and you return it. Or it was in the cache, and you just, update the life duration, because most time, if you have something in the cache, each time you retrieve it, you update the life duration. You don't have to. It can be a business rule, but that's what most people do. So that's what happened when you read something in a setup where you had Redis and Mongo and all the stuff. Now, to create something, each time you create it, it's pretty straightforward. You have a document, you get the ID, you insert the document into the database. You also insert this in the cache because that's what you should do. You should also probably set up a live duration, which I have not done, which is probably a bad thing. Maybe there's something automatically set up somewhere, which I realized just made a mistake, but that means that the more stuff you have to do, the more likely you are to do stupid things like I did. So it's better if you don't have to do it. Same if you update the document, you update the doc, you refresh the cache. Also wrong. You should actually you update the cache and you update the search engine index, which yes, we did index the document as well. Which is good. I forgot about that. It's not, when you update the document, it's not just about updating the live duration. I should actually be also updating the state of the document in the cache, which I'm not doing here, which is bad. So another thing I've missed. When you upsert the documents, it's update and insert at the same time. So it doesn't matter if the document doesn't exist, you just create it. And of course, you also update the cache and update the search index, the full text search. So basically, update Redis, update Elastic. Delete, same story. You remove the thing from the cache and you remove it from the index thing. That's a lot of stuff to do. What could possibly be simpler? I don't know. Maybe you could use Couchbase. Told you it was an extremely opinionated demo. So let's go back to our code. And actually, we don't need the cache thing anymore because Couchbase has an integrated cache. So the CRUD service doesn't have cache dependency. You can see I'm not using the cache here. And the search engine is not there as well because I don't need it because it's the same database. It's just a different index. And there's a reason why this works, which I'm going to explain you right after. So I don't need to create the cache implementation because it's already in Couchbase, which is nice. I don't need to implement index and delete because it's already automatically done by Couchbase, which is great as well. And so if I go back to my CRUD interface, there is no indexing to do for the search engine. There's no update to do in the cache. Everything's done automatically. It's much simpler. This code actually works. I haven't tested the other, if I'm honest, and it shows. But yeah, much simpler. Something cool I want to show you as well. So we, for JSON, you can do select this field and this field from this bucket where type equals whatever. You can change the consistency because we are a distributed database and consistency is important. You should have the choice in consistency. If you want consistency, which basically means every node in the cluster agree on something, it's going to be slower because you need to ask every node. Sometimes you don't need that. If you're Twitter, you don't care about consistency. If you don't show the latest timeline, it's fine. You can not care about this. But the point is, there's some application where you actually need that all the time. It's probably an ERP, and some application where it's on a per call basis. And the good thing with Couchbase is that you can actually decide of the consistency level all the time, and it's just a query option, which is cool. And a quick stuff about search. There's different ways to do search. You can do I'm going to call that an elastic-like search, which is basically creating a full text search request and putting all the things manually. And it's great to do faceted search. It's great to do complicated things. It works. It's there. Or what you can do is just use SQL because our SQL engine is in the same database as our full text engine, all you need to do is to just say, actually, just use that full text index, which is the bit I'm highlighting here. And this is the name of my full text index, and it's just going to work. And usually, to do that, and to make sure that you have the right select clause as well, what most people do is they query Elastic. Elastic gives them maybe the idea of all the documents, but you don't always have the whole document. So what you need to do is go back to your document database and then do a mapping between the IDs that return the result from the search engine and the actual database. And then you can give an answer. Worse than this, most people have their security scheme in the database and not in Elastic, which means that you get something to Elastic, you get a list of IDs, you get the list of IDs to your document database, you fetch a document, and then you do probably another query to map the rights of the actual user that's connected to the permission table or to the group or whatever. So basically you need to do a join. And the good thing is, I don't have the example here, but you could just add from something, join on groups, whatever, and you would actually get your result without having to query Elastic and then Mongo and then do a bunch of things. So yes, very, very, very opinionated demo. Do you have any questions on that demo, by the way?
No questions.
Yeah.
What do you store on Couchbase? Documents or?
What do you store on Couchbase? Do you store documents or table and columns? It's a document database, so it's all JSON. You don't have to store JSON. You can store binary data if you want. If you store JSON, then you get all the magical powers that you get from the search engine and the full text engine and all the stuff. So it's mostly a JSON distributed database. Yes, it's a document database that's not relational, but that allows you to do relations, which is weird, but it works. So you can do joins on different structure. We have different structure, we have different buckets. Inside the bucket, there's a scope, there's a collection. I'm going to tell you everything about this in the coming slides. Because the reason it works is, usually when I say that, people are like, well, you must have made some kind of trade-off. That's not possible. It shouldn't work. You shouldn't be able to do all of that into the same database, which is true. You probably shouldn't, but we did it. So how is Couchbase different? It's a mix of services that live next to each other. So instead of having a very, well, not a very small database, but instead of having one database that does everything on several nodes, you can actually do different things on different nodes inside the same cluster, but they all talk together magically, which is the value. So yes, we do integrated caching, which is basically storing stuff in RAM. Key value access. Key value, if it's JSON document, that's great. If it's not JSON, it works too, but you don't have access to all the other cool stuff, which are the relational capabilities for our SQL querying engine, the full-text search. You have something for operational analytics, which is basically instead of writing stuff like this, you write them like this, and it's faster. That's the quick pitch. We have an eventing service, and then we have something very nice, which is mobile replication. That I'm not necessarily going to talk too much today because I probably won't have the time to do it, but that's all right. Let's start by a simple statement. The way you store something defines how efficiently it will be retrieved. And that's sort of the value prop of Couchbase. One of the first things you learn at school is data structure. When you're in a computer science course, you learn the difference between a hash map and a linked list. There's very good reasons for that. One's going to be more efficient to do something, one's going to be more efficient to do something else. If you're a general purpose database, you're not efficient to do something. So you need a specific storage engine to be efficient at doing full text or at doing search, which is why we have indexes, which is why we have different storage engines. Now that we've said that, this is awful blue. Looks better on my screen. We do a whole bunch of things. So it's kind of the meta slides that show all the stuff that we do. So you can access everything for SDK and API. It works on-prem, on your virtual machine. It works bare metal. We have a Kubernetes operator that works great. We have something called Couchbase Capella, which is our managed database, which is how we make money. So cloud.couchbase.com. Free trial, no credit card required. Please try it. Cloud.couchbase.com. So that's the way you can run it. There's a bunch of services to do things magically, like integrated cache. You don't have to think about it. It's there. Identity storage. We do geo-replication. That's one of the things we are pretty good at. It's syncing stuff between clusters or syncing stuff from a cluster to a phone or a local database. I'm saying phone, it could be a Raspberry Pi, it could be anything. It's written in C. If you can compile it to something, it works. If it's in C, you can probably compile it to anything. Probably. So we're good at sync. That's one of the things that we do well. It shards automatically. That's important. If you don't have experience with distributed database, you might not know that, but sometimes when you want to write things automatically into different nodes in the cluster, you need to decide as developer where that document goes on which node, which sucks because you shouldn't have to think about this, but sometimes you do. And if you think about it and you come up with your own sharding function, which is basically saying, and that's a terrible example, everything that has a first name that starts between A and C go in that node, and between D and F go in that node, etc., etc. Actually, there's some country where the name distribution is going to create hotspots because there's more names statistically that start between A and F than between Y and Z. So you know that the node that with Y and Z is not going to have any traffic. You know the poor node that's between A and C is going to be ruined with so much traffic. So we do that automatically. You don't have to think about it. And I'm going to explain how it works soon. Multidimensional scaling is amazing. It's the ability to make sure that you can size the nodes based on the service you're using appropriately. If you have a query running, there's a couple elements. Maybe a query planner. So that's the thing that analyzes your SQL query and then do all the computing and the weird stuff to make sure that it works. And there's the index service that basically stores the data in a way that's very efficient for it to be retrieved by the query node. So basically, you want to load up the indexing node with a lot of RAM and the query node with a lot of CPU. And that's what we allow to do with multidimensional scaling. We don't really care about the size of the machines. It can be completely heterogeneous. You decide what you want based on the use case that you have. It's true for index versus query. It's true for write heavy loads versus read heavy loads. You can also size your clusters according to those problems. Because we can sync, of course, we do high availability, we disaster recovery. You know what happens if the meteorite crashes on your data center? Terrible thing. How do you recover from that? Well, we have a solution for that. Maybe not a meteorite though. So that's on the cluster side of things. It's JSON, it's key value, it's SQL, it does a whole bunch of things. I'm spending too much time on that slide. Let's move on. So that's an example, that's a visual example of what multidimensional scaling will give you. We have, for now, probably more to come. different services: query, index, data, full text, eventing, analytics, and the cluster manager, which is the zookeeper of Couchbase in a way. You know, zookeeper, it's the thing that's it's the zookeeper. Make sure that it originated from the Hadoop community, and so Hadoop, there was some elephants, there was some pigs, there was some, and there was a zookeeper, and the zookeeper role was to make sure that everybody was agreeing on things. Don't take too much data, just share the data. Imagine that the data is food and the zookeeper is feeding each pig node or Hadoop node appropriately. That's what zookeeper does. That's what we have here is the cluster manager. It's on every single node. It's written in Erlang, which might be weird. If you're not familiar with Erlang, Erlang is a language that's originated from Ericsson, I think, in the 70s or the 80s. So telecommunication, lots of real-time use cases, lots of massively distributed use cases, and I actually built a language for that. Jump into 2006 or 7, CouchDB, Apache CouchDB, built by Damien Katz before Node.js. He thought of doing a database that is exposed with a REST API and that uses JSON documents before Node.js, which is insane and visionary. So CouchDB is the ancestor of Couchbase, because in 2010, we've merged, some people will say fork, we've merged CouchDB with Membase. Membase was a distributed key value store in memory. So we merged a distributed key value store with a JSON database with a REST API that also had a MapReduce engine to write something called views, which was basically an index that you can use to query your JSON document. And MapReduce usually scares everyone, but it's actually quite simple. It's just a function that goes through every document, and the input of that function is an index. So basically, it's an index building engine. That's what people do with Hadoop. Hadoop is not complicated. I was going to say it's just JavaScript, but they use Scala instead. So yes, indexing, query, data, full text, eventing, analytics, you can size them however you want, and that's super useful. Now, how do I know where is my data? How do I know if it works or if it doesn't? So many questions. Let's talk about the data service. So we saw JSON. JSON is kind of an auto table in the sense that if you look at the architecture of a JSON document, it has field and field have types that hopefully looks like a table. And that's what the JSON document is it's self-holding table structure. So it maps somewhat easily to a table format, but we have complex objects like arrays and objects, and arrays of objects and objects of arrays of objects, a little bit of everything. So it's a little more complicated sometimes. The way we store things in Couchbase, to go back to the question you asked earlier, if it's relational, then you need to join stuff on other stuff. Traditionally, before Couchbase 7, you would join only, you basically only had that, you only had buckets, and you would join things across buckets or across properties, which is not great. We have enriched our granularity with what we call scopes and collections. So basically, a server is a cluster, a database is a bucket, a schema is a scope, table is a collection, a row, the line of your table is a JSON document, and then the value, inside the row is a subdoc. Because you can do subdoc access as well. I forgot to mention that, but you can actually just change one small part of the document if you want to, which is great if you want to be consistent and fast. Like, let's say you're storing a 20 megabytes document. You don't want to get that 20 megabytes on the network. You can just ask the exact field that you want, which is actually pretty cool. All without using SQL, because if you use SQL, you go through the query service, and then it goes to the index service. So you're on the milliseconds answer time. If you stay key value, if you stay integrated cache and everything, it's usually sub-millisecond. It's so much faster. Things are stored in a bucket. A bucket contains scopes and collection, whatever. I talked about sharding. Sharding is how do you split your data across the different nodes of your cluster. The way we do this is we split each bucket into 1024 virtual buckets, virtual partitions. And we have a hash algorithm that's going to make sure that this thing actually works. And for this to work, you need a stateful protocol, because if there's a hashing algorithm that decides where the thing goes, it needs to be common to the client that's writing or reading the thing and the server that's writing or reading it or serving it. So basically, each time you use a client library, that means that you need to use our SDKs. We are coming up with a data API. We are coming up with something a bit simpler, but right now you have to use the Couchbase SDK. And the reason for this is because there's a state shared between the cluster and the library. The state is the cluster map, which is how my buckets are split. I know that virtual bucket from 1 to 10 are on shard number 2. I know that virtual bucket from whatever to whatever are on shard number 3, etc., etc. That was true before Couchbase 7. Now the granularity is even smaller because we have scopes and collections. So basically, there's supposed to be an accident at some point. Oops. Maybe on another slide. That's all right. We'll simulate an accident later. So basically, the client knows what the cluster map is. It knows where the shard is, so it can actually get the shard exactly on the right node. And if it's not there for some reason, because stuff happens, it still knows that the replica of shard 5, shard 5 is on another node. Because if it's a distributed database and things go fast way and things go terribly wrong, you always want to replicate your data. So it's automatically replicated. You don't have to, but let's say you have a 3-node cluster. We advise you to have 1 replica. If you have a 50-node cluster, you can have up to 4 replicas, so that if you lose part of your cluster, some of the shards will still be available as replicas, and so you still be able to actually get the data. Which goes back to that consistency discussion we had earlier, is that if consistency is not important for you, you can still give an answer. If it is, or you know that you won't be able to give a consistent answer, so you can send an error instead, and then fix your stuff. How does it work? It's a key value store. So when you write something to the data service, you have a key and a value. If the value is JSON, you can do all those amazing things. And so you have a key. The key is hashed using apparently a CRC32 hashing algorithm that is shared between, again, the cluster and the client. So it knows that basically I'm going to compute a hash about this, and the hash that starts from this to this goes there, etc., etc. So that's the reason why it works. And there's going to be lots of animation. That's going to be very uncomfortable. That is very bad. All right. What happens when you add or remove nodes? What happens when you add a node? I used to have 3 nodes. My 1024 shards virtual buckets were all equally distributed on 3 nodes. Now I have 2 empty nodes. I need to redistribute everything equally. So you do what we call a rebalance, which any other database called a rebalance, really. And basically, it's going to rebalance both the active shard and the replicas. There's only one version of an active document at one time, which is great because that's what allows you to enforce consistency. If you take a database like Cassandra, which is a very good database, when you want to have consistency, you need to have quorum, which means you need to have a majority of nodes that agrees that this is the most recent version of the data. Because your data is distributed on several things and there's no distinction between what is active and what is replicated, it needs to ask what is the most replicated version of the data to make sure it's probably the most up-to-date, which is a terrible thing to do if you want to be fast, because again, the more things you have to agree with, the slower it's going to be. Here, because you have a distinction between what is active and what is a replica, and because it's a key value store and because it's in memory, if you do one document, it's going to be extremely fast. It's going to be sub-millisecond. Because we do that distinction. If you're a multi-master database, there is several versions of the active document at the same time. They all need to agree. It's going to be slower. So let's rebalance a bunch. Oops. Whoa. That was the fun part. So what happens if something goes wrong? like we've lost that node, which had shard 1 and shard 3. And there's probably an animation that I've missed. Yes, right. So before everything turns south, shard 1 is here, and it's here. So if you look at closely, oh my God, we've lost that node. That's terrible. And then automatically, what was available as a replica becomes available as the active version of the document. It only works if you have one node that fails at one time, because if you have more node that fails at one time, then it's a more difficult discussion. It's called a split brain, and it's a terrible things to do, and usually it requires manual intervention to make sure that everything is to reconvince in a proper state. All right. I feel like we've already talked about this quite a bit. So everything starts with the data service, and there's this thing called DCP. It's the database change protocol. You can think of this as Couchbase's own internal Kafka or streaming service. It's our streaming service. It moves data changes across all the different services automatically, so you don't have to think about it. And so that's the trade-off that we did. The trade-off that we did, we came up with each most efficient engine for each data problem in the same database. But the problem is, well, you have several things, so you need to learn several things. You need several libraries to access it usually, and you need to maintain them. The trade-off that we did is we built a complicated platform that sort of unify everything with only one SDK, one way to access it, and with the fact that you don't have to operate other different solutions. It's just Couchbase. Now, usually people are you as good as Elastic, or are you as good as whatever? Most of the time, for 90% of the use case, yes. Can you see Couchbase as the 90% database? Probably. That's a valuable thing to say. We do everything. Well, not everything. We don't have vector search yet. Working on this, like everybody else is. We do a lot of stuff. We do it pretty well. But yeah, if you want to have something very, 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 very specific, there's probably something that's completely dedicated to that problem that's going to fix it better, for sure. Our use case is basically replatforming. If you're replatforming things, if you have several solutions, and you don't want to learn several solutions and manage them, well, you can use Couchbase. XDCR, I'm going to talk more about it in a minute. We have some connectors, of course, for other solution, like say Elastic. If you want to do, there's some pretty complex geospatial search that are really hard to do, and that we don't do as well as Elastic, for instance, yet. And so some people sometimes need to index stuff on Elastic. It's fine, or use Kafka or Spark.
All those services are going to be running with no merit. You're not going to need it.
Oh, you can choose.
So, for example, I can deactivate not using the Fulltext search, for example.
Yeah.
Or
you can choose which service you want on which node. You can collocate services as well. So if you want to collocate your query node with your index node, that's possible, which means that you would remove the network latency from the query node to the index node. And in some cases, it's a very interesting thing to do. You can actually shard your index manually. If you shard your index manually, that means you can size as well more appropriately. You know that this very efficient, this very big query needs to go on this node, and so the index there, the query planner is going to say, well, use that index on that massive node. You can do all that stuff. In the Enterprise Edition. Community Edition, everything's activated by default. And unfortunately, cannot change that. But if you only need data service and you just want to do very fast key value and CRUD operation, that's fine too. And we had a lot of people using it like this, and yeah, it works pretty well. So quick trivia. I talked about CouchDB. It's Erlang and C. I talked about Memcache was C. So basically, you have C, Go, probably Go as well. I think there's a lot of C in there. This is Java. So yeah, it's a platform. There's many things that stick to each other and that do stuff. Thanks to DCP, the database change protocol, which is well, that's one of the coolest thing about Couchbase. It's also what we use to synchronize data across cluster, to do active-active replication and all that stuff. So it's actually pretty cool. We have a customer called Trendyol in Turkey, and they actually created their own DCP client in Go to create their own connectors to various solutions. And of course, everything's available with our own SDK, blah, 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 all that stuff. But you only care about Java because that's why you're here, of course. We don't have Perl yet. One day. Oh, yeah, so actually, that's a good point. Most of the time, when you have all your clients, there's probably going to be a load balancer in the middle. Because we're a stateful protocol, it's not really a load balancer, so you probably you don't have to do that. You can just use straight up the SDKs. They don't have to, because of the sharding that's automated, because of the stateful protocol, they will go to the exact same node. There's no point into moving them to one node or the other. Some of the cool feature of our SDKs, a bunch of things. They're compatible with every services. You don't have to use every services, of course, but key value views, that's the now deprecated MapReduce engine we had, query, analytics, Fulltext, and the good thing about our query service is that it's fully integrated with the Fulltext service as well. Some cool stuff you can do field level encryption, which is nice. We support transactions. Of course, it's not on by default because transaction in a distributed system is expensive, because it means you also have to make sure that every node in the cluster agrees. Even if the fact that we have only one activation of a document makes that faster and easier. So you can do a transaction with SQL as well, which is great. So yeah, one cluster to do all of that. No need to, bring up the Redis library and the Elastic library and the whatever library and all that stuff. What time is it? How much time do I have? An hour?
Yes.
No. All right. I have a couple more slides, and we can start playing with more code. So sync. Whoa. That was weird. Okay. That's not supposed to be here. Moving on. Cross data center application. That's the thing that's actually it's DCP used across different clusters. So what it means is that you can replicate all data or filter the data. You don't have to replicate everything. It's going to become very useful because everybody's, especially in Europe or in China, it's all about regulation, and you cannot move that data to another country and all that stuff. So if you can't, but if you want to keep the same stack, well, that's a good solution, because you can filter every replication by bucket, by scope, by collection. You can add a regex if you want to do crazy filters like this. Usually people have just something called type, and they just filter on the type. That works too. You can define all your filters. You don't have to use filter. You can just sync everything, push or pull or both. So active passive replication or active active replication. This is one of our best qualities, in my opinion, in terms of distributed database, and that's why that's one of the things we do great because of our architecture, more so than other relational databases that were not necessarily built with that in thought. Couchbase is still fairly new, so we had the time to update the architecture to more newer needs like this. But basically they work the same. It's just a role, a write-ahead log. There's a write-ahead log in Postgres, there's a write-ahead log in MySQL. So basically each time you write something, there's a stream that writes everything. And so you can pick up that stream and you can replicate that stream somewhere else. That's how replication works in relational database. That's also more or less what we do with DCP. DCP is our own replication stream. Since Couchbase 7.1.2, I think, it can be used to do change data capture, which means that the order is guaranteed and you can use it as a proper streaming solution, which is great. Also a bit expensive because, well, it can be a lot of data. What we used to do was buffer stuff, and if you buffer mutation, then it's not really change data capture. It's not really exactly the state that you want to reproduce, so it's a bit different. But now we can do it. We have customers that have very crazy setup. They have, they work in the travel industry. So it's a very, very transactional use case. They basically, each time you book a room or a flight, you go through their system, and they only use key value. So because they want to be fast, and they simulate transaction. Well, I mean, they do a transaction by doing what we call a two-phase commit. A two-phase commit is basically a manual transaction. You have a document that's the state, the initial state, and that's the thing that you should roll back to if something goes wrong. You do your stuff, and you just act as a journal. You list the modification, and those modifications you did, you can compare to the initial document. If something goes wrong, and you can go back, you can roll back. So just iterate slowly, and then if something goes wrong, go back to initial document. It's kind of a transaction. That's how they do it. That's how everybody does it, because you remember at school when they told you that the bank system was the best example to talk about transactions, because you cannot withdraw the same amount of money several times. It doesn't make any sense, because it already existed 20 years ago. And do you think they had a massively distributed cluster across the whole world that would actually work? No, it doesn't work like this. It's log reconciliation. So it's a bit like a two-phase commit. You do your stuff, and then at some point you synchronize all the states, and you make sure that it's actually true. So that customer, they use key value to do transactional use case. And when they want to run query, what they do, because they want to stay fast, they leave that cluster alone. There is an active passive replication to another cluster with a buttload of index and query node and analytical nodes, and that's where they run their analytics queries, because they really want to leave their operational cluster alone. So it's all key value. It's super fast. It's manual transaction. I mean, these people wrote their own transaction manager in C like 30 years ago, so they're really badass. 40 years ago now, I think. So anyway, they have their key value cluster. They have a replication to the analytic cluster. They have another replication to disaster recovery or backup cluster. And everything is ringed, because they really take disaster recovery seriously. So they actually have 2 operational clusters, and then 2 analytical clusters, and then 2 backup clusters, and everything is replicated, which seems a bit overkill, but it works. These people, when talking about overkill, have 2 terabytes of RAM per machine. It's insane. And that was in 2015, so that's probably more now. So yes, you can decide what you want to synchronize. Active-active works pretty well. You get encryption, of course, because you don't want that moving data to be not encrypted. So all those things. We do sync. We do it well. We also do it on mobile. Any question about the cluster sync? It's DCP that just moves stuff around.
It's as crazy as the speaker thing.
Yeah.
Similar to managing from the. I listen many terminologies about.
In French, we say zookeeper. And zookeeper means it's a pun. It means zoo who cries, because it's such a nightmare to manage zookeeper. Okay. So we call it zookeeper. Zuki cries and Zuku cries, and yeah, it sucks. Zookeeper it has gone much better than it used to, but yeah, 15 years ago it was awful. Now it's okay. It's still one of the things that Afir hasn't broke. Afir is a consultant in distributed system, and his daily job is to break distributed system. And he has a great blog. I think it's called Call Me Maybe. And he has all the studies of all the distributed system that he tried to break. And the only one he did not break, as to a couple of years ago, I'm not sure if he did now, was Zookeeper. Nice. So, yeah. And it's Java. Like everybody, oh, Java's dead. You cannot do distributed. Yes, you can. It works. Zookeeper. So Couchbase, trade-off. Yeah, it is a platform. It can be a little bit complicated to administer, to manage. I think the management part, the issue is more on the configuration and the sizing of all your nodes, more than the actual ops side of things, because Zookeeper was something that broke pretty often. I think Couchbase is a bit more stable, but it's still hard to And again, talking about Zookeeper 15 years ago, things have gone much better for Zookeeper now. But yeah, I think the hardest problem with Couchbase is that it does so many things. You can do so many choices. And we offer you so many choices that, in a sense, it's great because you can do exactly what you want. But it's like a little bit overwhelming because you can do everything that you want, so it can be prone to error as well. It's the curse of every platform. If you talk about Kubernetes, Kubernetes is a platform to build your own platform. So it's a generic thing that doesn't answer anybody's needs, but come with the complexity of being able to answer to everybody's needs. Every platforms are a bit like this. Every platform needs to be tuned up to exactly what you need. That's part of the beauty of that platform. That's part of what makes it complicated, and that's one of the trade-offs that you have to do. So we sell professional services and support, of course. Sorry, any other question? All right. So talking about sync, we do a lot of sync. Sync between clusters or sync between devices. I'm going to be pretty fast on this because I don't necessarily have time to, well, I don't know, we'll see. Couchbase 3.0, mobile 3.0, some of the good stuff that happened. It used to be only Android and iOS. Now we have a C library. And so, as I was saying earlier, if it works in C, it should work on anything that compiles in C. So it should work with pretty much anything. Actually, so a couple cool things happened in our open source community. The only officially supported SDKs for mobile are Android and iOS because it's the biggest user base that we have. But some people did different Couchbase Lite version based on the C version. So we have a Flutter version that's written in Dart. So you can build multi-platform mobile application with Couchbase Lite with Flutter. Someone just announced this with Kotlin and Compose, I think, is their Jetpack thing. I mean, JetBrains has a framework called Compose Multi-Platform, and it's basically a multi-platform framework to, desktop, web, mobile, you name it, they do it. It's written in Java. And so someone from our community actually built something called Couchbase. So it's or Kotlite. Is it Kotlite? It's Kotlite, I think. So Kotlin and Couchbase Lite to do multi-platform application. Some people did a Rust binding. A French customer called Doctolib. They work in the health industry. And so the main use case, if you're a liberal and you go in the countryside and you need to invoice someone, but you don't have a network, and you still have the card reader for the healthcare security, for the health security thing, and so it's IoT basically. And so they build their own card reader in C, integrated Couchbase in there, and so now they have this super well offline working reader, which is great. So there's a Rust version of that. I'm currently trying to build a stack with Tori. Tori is the Electron competition. Electron was this desktop thing that allows you to run any Node app on your desktop. So that's basically Slack, Spotify, anything that runs on your desktop on this using the thing that steals your RAM. That's what it is. The thing that steals all your RAM, it's Electron. And some people have rewritten this in Rust. It's called Tori. And Electron was using SQLite. Would be great to use Couchbase Lite with Tori. So that's my side project at the moment. So anyway, we do see we have the sync gateway. The sync gateway is like this is the thing that does the synchronization with business added value. I'm going to talk more about this later. We've added field level encryption. We've added a whole bunch of things, and you can do SQL++. SQL++ is our own brand of SQL, and it's also available on mobile. So the SQL for JSON that you can do on server, you can also do it on mobile. You can also do full text on mobile. It's great. Quick overview of what an architecture could look like. This is Couchbase Lite. This is the local database that runs somewhere. It's basically a JSON wrapper on top of SQLite. We try to do our own local database, but yeah, SQLite remains fantastic. So it's basically an overlay on top of SQLite with a synchronization protocol called Blip. And Blip, it comes from the CouchDB days as well. Can synchronize automatically to other Couchbase Lite instances, so you can do peer-to-peer, which is cool. Or the Sync Gateway, which is this REST API that we've put on front of a Couchbase cluster. And that gives you basically user management, or that gives you synchronization channels. Because, of course, you don't want to synchronize the whole NoSQL database to somebody else's phone. So you need some primitive to make sure that you don't synchronize a whole bucket or a whole scope or a whole collection. So that's what it's giving you. I feel like I've talked about this already. Yes, if you like Java, well, we now have a Kotlin version of that API, which is fantastic. I'm going to talk about all of these, but I'm going to talk about the one that I like. And I think you're funny. Ugh. Right. So iOS.NET, I'm not sure it's actually still supported. That's weird, because Xamarin has been bought by Microsoft. Anyway, iOS, Android, Windows Phone. You can do desktop application with Java. I actually gave a talk almost 6 months after the first time I came here with Raspberry Pi running it. It was a chat app, and everybody could download the version of the chat on their phone. And we did a peer-to-peer replication across all the phone in the conference. So I had a chat window open on the screen, and everybody could start typing. So you can imagine all the word, like the terrible thing that happened on that screen. But it worked, which was great. So client-side field level encryption. What is it? Why is it important? It also works on the server side of things, by the way. Client-level field encryption means that the data that's on your phone, on a per-field basis, not just the whole document, can be encrypted and stay encrypted and arrives synchronized to the server encrypted. So if it's encrypted in the server, you cannot use it, you cannot query it. But at least, if you need to get it back, you can send it back to you. It's going to be unencrypted because the encryption key is stored in your device. So that means that if you work in healthcare, for instance, we have a lot of customers in healthcare, you don't want to synchronize everything. You can still synchronize it, but keeping it private. How does it work? Is there animation on that slide? Yes, of course there is. So each time you create a document, there's a listener that basically knows that this thing is going to be encrypted. It's going to encrypt it. And there's wait, that's what I wanted to say. So you store it, you tell it this thing needs to be encrypted with the actual unencrypted value. It's stored locally, it's encrypted. And when you nani? Yeah, it should never go. I mean, you can sync back the encrypted version. You don't care because the encryption library is still on your phone. So I'm afraid. Okay, so yes, this is the local side of things. And if it's local, everything works. The replication is the thing that moves the data around. And if you need to move the data around, then there is a listener. It gets encrypted and it gets replicated. It's important to talk about replication links instead of just replication to the server, because again, you can do crazy things like peer-to-peer replication. And then, well, actually, I lost the last one. And then the last one is, what was this? That's this is encryptable. This is one, and this is how it syncs to something else. It's the encrypted value, the algorithm that's been used to encrypt it, but you're missing the key, so of course, it will work. Another very cool thing we added about 3 years ago is called predictive querying. Predictive querying is the ability to embed a machine learning model in your mobile app, in your local database. Predictive querying gives you the ability to query what is the closest data to the one that you have stored. So basically, I'm not sure I have a demo. Let's say you have lots of cars, then you have a categorizer model, and the thing tells you it's 99% close to the reference image. You saw lots of image. You can build an index so that when you take a picture, it's going to get you all the image that looks the closest to that image by order of closest looking image. that's one example, that's a visual example, but you can do any model, and you can probably do lots of interesting things, but I lack imagination when it comes to machine learning because it's so overwhelming. But it works.
Expensive operation to process all these kind of.
You don't train the model locally. You have a local model, and you can use that model. If it's a simple image, it should be fine. You don't need like a crazy GPU to infer the image on the phone. And those are becoming quite powerful. So yeah, there is a 90% probability that the image you input is a mountain. Yay. We added that during COVID, so obviously nobody cared, but now people care, so that's great. You can do replication. Replication goes two ways. You can push or pull, or push and pull the data. That's important for the next. Whoa, fantastic. I mean, that's just how to set up a replication in Java. You don't have to care too much about this because it's actually pretty straightforward. You have a local database, you have an endpoint that says go and listen to that address. The interesting thing here is that it says WSS, which is a web server socket, which means that it's a socket, which means that it's live. So instead of just pushing things manually, if there's a socket open, you have what we call a live query, which basically it will automatically update your screen if something changed. You don't have to rerun the query. There's a socket open that's going to give you all the replicated documents live, which is nice as well. And then you create a replication, you start with push or pull replication. The reason I wanted to talk about this was just to talk about that. And that's the cool bit. We have customers in the travel industry. So inside a boat or inside a plane or inside something that doesn't have network, basically, you can still sync stuff to each other using peer-to-peer replication. It's just a local database will act as another sync gateway. That's just how it works. It's very simple. Instead of syncing and giving the URL of the sync gateway, you give the URL of another database. Usually the question that comes after is how do you find the other URL in the same network? Depends. There's a lot of stuff you can do. What I used to do was use DNS, because DNS is a very old protocol that has broadcasting and advertising capabilities. So you can say to a DNS server, it has a registry, and you can register your service as this is my URL, and this is the port you can use to use that service. And this is how UPnP and DLNA work. UPnP and DLNA are the video industry standards that make sure that when you plug a box thing, a set-top box, internet box, whatever box, or a TV, smart TV, in the same network, you can, or Aircast or whatever thing that it's called for Apple, or Miracast, or yeah, it's just DNS, just DNS. So basically, you can advertise yourself as something synchronizable, and you can query that thing, and so you say, oh, this point is synchronizable, this one is let's sync. That's just for the discovery. You still have to do the security a bit differently, because unless you want everybody to synchronize publicly, which is what you want for a set-top box, you probably want to set up some sort of security. But at least it's a good way to advertise devices, and so you can have all sorts of edge architecture. You can have mesh architecture. You can have more central architecture. Basically, you do what you want to do in the way you want it to do. We don't have to go through that. Oh, forgot about that. So cool thing, if you go offline and you go online again, some things might have changed in the middle. How do you manage that change? It's called a conflict, and you're bound to have conflicts on your phone if two people touch the same document and modify the same document, but one of them was online. How do you decide which is the right version? It mostly depends on what you do and what your app does. It is a business use case. So what we do is we have conflict listener. You can set up your own automatic conflict listener, which is going to be basically a programmated rule, like last byte win, for instance. You could do that, but that's not fun. So you can implement custom resolution based on anything you want. If you want to show a screen like a merge, like a commit merge screen, you can do whatever you want. The important thing is you need to know when there's been a conflict, and you need to be able to fix it. I think that was my last slide. Maybe not. I've talked about live query, so we don't care. All right, I have 3 minutes left for questions about Spring, for instance, because I haven't talked too much about Spring. So. Yes.
I did have a question before. You talk about like the server and the replica. That you have like 3 nodes and each node has like an active part and a replica part.
Yeah, or 2 or 3. Microphone next to you. Let's repeat the question in the mic.
And I was thinking, each of the active database have a replica shard or more, but
1 or more, or 0 if you want to live dangerously and you only have 1 node. You can have 1 node.
And I was thinking, like, how does it like when you update a shard? Like, you're gonna update the active one, and then it's gonna spread to the replica.
When you rebalance a shard, you mean, or
whatever. I got a shard with like some data in it, and I'm changing the data, so the inside of the shard.
you cannot change the shard. The shard is completely hidden to you. You only change documents, and documents. The key of the document has a hash, and the hash is assigned to a particular shard.
Yeah. So if I change the document, what's gonna change for the shard?
If you change the document, it will have the same key. If you create a new key value pair, like so, if you move a document, you change the ID. If you move the ID, there's a new hash, and it's going to move to a different shard probably.
Okay.
Everything is based on the key side of things. So officially, you don't have access to that sharding function. Some customers do very complicated things, and sometimes they want to make sure that the data is written close to the previous version. We have some people that did time series use cases, and if you have time series use case, you want to write everything next to each other because usually you want to query everything next to each other as well. So they came up with some custom hashing function to make sure that everything was written next to each other, which is interesting. We have a new support for time series. It's more of a we give you an ability to do a time series. If you're doing monitoring, you probably need a proper time series database. If you're doing monitoring something simple, that works. We store things into a document. Document has a 20 megabytes size limit. So if your series is completely outgrowing the document, then that's already a pretty big document, though. Pretty big series.
I might have another question. Basically, Couchbase take all the entry, and instead of having to pick our way each time, we just have a global interface to use it.
Mm-hmm.
So it's clearly really permissive. That's the whole point. It's you can do a lot of things and use the plain text to search, for example.
Yeah.
Is there in a internal protocol to avoid like injection or this type of thing? Because the more permissive you are.
You mean SQL injection?
Yeah.
Yeah. So, well, yes and no, just like SQL. So if you use our SDKs have parameterized queries. So of course, your parameters, if you add your query as parameters, everything will be escaped and all that stuff. But yeah, so actually the worst thing, probably not injection. One of the things we allow people to do, and I haven't talked about this, the eventing service allow you to have what we call user-defined function, which is basically like a trigger in a SQL database. And so you can write anything in JavaScript and you can do it. So yeah, it's the most open thing we have. Of course, you should not allow anyone to upload a user-defined function or a trigger, but that's probably the most dangerous, I guess, thing you could do. You can do it in JavaScript, and if you have the analytics node, you can do it in Python, which is interesting. It opens a lot of different use cases, because if you can run a Python function each time something has changed, and that's on your analytics node, there happens to be a GPU, then you can do a whole bunch of interesting machine learning things. All right. Well, thanks for coming. Thank you.